Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. Now let's move to our next subtopic. Thanks. Before that, I would like to thank to all of you about your interesting video. All of your video is very good and very attractive, and I hope all of you have watched your friend's video and try to comment your friend's video so we can improvise it for the next session. Okay, today we'll move to the simultaneous equation topic, which is still under chapter 2, which is algebra. Before we go, we move further in our subtopic. Let us watch this short video relating to this subtopic. So we can say that this simplification is a concept where we would like to solve two unknown in the equation where the other equation is given. So we already learned it in our primary or secondary level or in metric or tertiary level. So I would like to just to recap it back the concept of the symmetry equation. So for example, in this equation, we have two equations. The first equation is y plus s equal to 5, and the other one is y minus s equal to 1. So we make this first equation, we label it as 1, and the second equation we label it as 2. So to solve this equation, we will make one of the variable the subject. So now the variable in our equation is y or x. So you can choose either one. So for example, here I take the first equation and I would like to make s as the subject. So we took the second equation. So the second equation is 2y equal minus s equal to 1. So we rewrite the equation. So make s as subject. And then we rearrange all the variable, all the numbers here. So the last equation we have is 2y minus 1 equal to s. So we say that as we rearrange this s and make it a subject. So next is we substitute this s into the first equation here. So I substitute the first equation and put it in the first equation. So now we have, for the first equation, we have y plus s equal to 5. We substitute this as with the value that we have before. So now we have y plus, in bracket, we just substitute the x, 2y minus 1 equal to 5. So we simplify it. So we have 3y minus 1 equal to 5. We simplify it again. We move this negative 1 to our right hand side. So from the sum from negative it become positive. So 5 plus 1 becomes 6. So we have 3y equal to 6. So now y equal to 2. So now we already have the value of y. So next what we need to do is we need to find the value of s. So we can use this value of y and substitute it to any equation that we want, either 1 or 2 is up to you. Let's say I take the first equation. So y plus s equal to 5. So now I already have the value of y. So I just substitute the value of y equal to 2 here. So 2 plus s equal to 5. And then we simplify it. And then we will get x equal to 3. So the solution of our equation is x equal to 3 and y equal to 2. Besides, we can solve this simultaneous equation by plotting two graphs. So it can be done graphically. So if you can see this, so the red line, the equation for the red line is x plus y equal to 5, and the equation for blue line is 2y minus x equal to 1. So this was the solution for this problem is the intersection of these two lines. So the coordinate of this intersection is 3, 2. So this is the x value and this is the y value. So you can try this example. You can discuss with your friend and let's see if you can find the solution for this problem. Besides, let's move to a real chemistry problem. So results from a mass spectrometry experiment show that two fragments of a molecule both contain hydrogen and carbon. This is the important information here. So the empirical formula for the first fragment is C2H5, which has a mass of 29 AMU, and the second has a formula of C8H18 with a mass of 114 AMU. AMU stands for atomic mass unit. So calculate the mass of the carbon and hydrogen atoms. So if we have these two equations, we can extract the information from the information given. So for example, here this is the important information given from this question 1 and 2. So we can extract this information and put it into equation, convert into equation. So now we have 2 carbon, 5 hydrogen, and then the mass of this is 29 mu, while for the second molecular formula is CH18. We have a carbon, 18 and 18 hydrogen, and the mass for this molecule is 114 mu. So we do it like this. So we convert it into a equation. So we have 2C plus 5H equal to 29 and XC plus 18H equal to 114. So solve it. Let's take equation 1 and make this 2C as a subject. So 2C equal to 29 minus 5H. So what you can do is you can make it a subject. So you move this 2 to our right hand side. But this one it will involve with a long work process, and we tend to make mistake. So what we do is, you can see here is 2C, here is XC. So what we need to do is we just try to convert it 2C to XC. So if you want to convert it, what we need to do is we need to times this equation with 4 everything. So if we times 2C with 4, we need to times everything in this equation with 4. So what we do is we can have 2C times 4 become 8C, 29 times 4 become 116, 5H times 4 become 20H. So next, we have it and we substitute it into the second equation. So that's why we have 116 minus 20H plus 18H equal to 114. So we simplify it. So we will get H equal to 1. So then we already have the value of H equal to 1. So we can use That's what we need to do is we will need to find the value of c. So what we need to do is we try to substitute. We can substitute h equal to 1 to any equation that we like. So for example here I like equation 1 because it's too simple to me. So to see, so I have to c plus 5h equal to 29. So since the h equal to 1, so substitute the h equal to 1, so we have to c plus 5 times 1 become 5 equal to 29. We rearrange it, we simplify it, so we have to c equal to 24 and then c equal to 12. So this is how we use the concept of simultaneous equation into this chemistry problem. So you can try to solve this problem, and we will discuss it in our tutorial class. Thank you.